All right, settle down, settle down. Let's get this over with. So, just as a heads up, I'm going to be ending class a little bit on the early side so that I have time to go and set up the room for the test, which I think probably most of you, how many people don't actually have, how many people have databases in a different section? I'm curious. Because it's supposed to be blocked so that like, yeah, okay, so you're all in it. We're all in this together. Okay, sounds good. Okay. You want to see what I've been doing instead of doing my marking? I've been working on a revision of assignment 4 for you guys. I think you're going to like it. This is like this is like a working demo type thing. It's up on CS Unix as we speak. Ta-da! It's a picture there. Enter if you dare. And it's a little dungeon crawler. The that doesn't quite show up very well. The
Orleans.
it doesn't show up on the projector very well because it's kind of dingy. But these are 3 doors in the background. This will show up better on your monitors. But yeah, you can like turn in the dungeon. It reorients the way that the doors are, right? And then you can go forward and find things in the dungeon. This is assignment 4. Oh, you found something cool?
Yeah.
There are a couple of cool things in there.
It's a demo stuff.
Yeah. Yeah. Anyway, so that's assignment 4. We're going to work our way up to this one. This is an application using MVC architecture, and we're going to. This is where we're heading by the end of the class. So, yeah. Oh man, I'm a little disappointed that the images are so dingy that they don't even show up on a projector. That's a little disappointing. Ah well. Even on this monitor, it doesn't look very good. I might do a slightly lightened version of the dungeon rooms because it showed up fine on mine. Bugs, am I right? Always something. Always something.
Well, you know, if they can have torches in Skyrim dungeons that are hundreds of years old, surely you can have torches in your dungeon.
I mean, yeah, it's fair. It's fair. But yeah. So the fun thing about that thing, everything that you would consider game data is held in an SQL database. So you're going to be querying an SQL database to like retrieve the room data and the data for like an encounter if it's in the room that you're in, which is indicated in the table. So you know, I'm still working on like hammering out the actual description document, but I just wanted to give you guys a sneak peek. Just, you know, I haven't been lazy. I haven't been doing nothing. I know I'm behind on the marking. I'm gonna do the marking as soon as that's done. I'm gonna plow through the marking, and then I'm gonna be incognito for a while I'm making the exams. So yeah. Anyway, if memory serves, we were talking about assignment 3 when we left off. I was explaining what an L system is. What's expected for that. Yeah. I can't remember if I like said everything I want to say about this. I'll summarize it in brief. So basically, you should watch the videos that are given right? Because they explain how the thing works, right? But essentially the idea is that if you have a string, substituting a character in that string for another string and treating those characters as instructions for how to draw line segments allows you to build kind of interesting looking fractals. And that's the whole point of the assignment. You don't have to do the front end anything. All you have to do is the algorithm that performs the string substitutions, which is, you know, not completely, like it's, I think it's, programmatically it's probably easier than the Conway problem, but, you know, neither of them should be complete brain benders, but, you know, so it goes. So basically the idea is if you have a string like A, B, and you have substitutions, like A becomes, you know, left A, right A, and B maybe, or let's call this B, and this becomes BA, and B becomes CC, something like that. If you take this string and you perform these substitutions on it, you end up with CC, B, negative A, positive A. And you can continue performing, you can then use this string as an input to another substitution step. And in so doing, you build up a longer and longer and longer string, which generates a more and more complicated and intricate fractal. So let me just show you the, inside the distribution file, there is a data file that gives you these substitutions. So it's not even that you're like hard coding the substitutions or anything. Patterns, JSON file. What are you going to open in? Don't do Visual Studio. Oh, pursuant to the campaign to try to have Visual Studio replaced with Rider, apparently PyCharm is also JetBrains. And PyCharm is like the Python IDE everybody likes and wants to use. So I don't see why we wouldn't do that one too, you know? How about you open with something normal? Like Notepad. Notepad is normal. That's all I wanted to see, right? So basically, you're given, you know, you're given a set of substitutions. Part of the input to the program is which substitution you are performing. You look it up. Anywhere an A occurs, you insert that string as a replacement for the A. Anywhere B occurs, you insert that string as a replacement for B if you're doing that pattern, right? The actual string substitution part is the trivial part. There are library functions that will do this for you quite easily, right? And if one library function isn't enough to do this for you, you can definitely use a combination of two library functions to accomplish this. But yeah, aside from that, it's just kind of managing the data that's flowing back and forth to and from the client. Does that make sense? Are there any questions about this? The point of this assignment in general terms is to attempt to prove to you that it doesn't take much code to do some cool math stuff. So we're going to do some cool math stuff. Sound good? Any questions? Okie dokie. All you need for this assignment is sessions, and you know, if we keep things moving today, we'll even be there by the end of today. So, now I know that there's a midterm coming up in the next period, and I know that people may wish to not pay attention to this in favor of doing some last-minute cramming for the midterm. But if I may be so bold, yes, I'm sure I want to exit. Good grief. Never wanted to open you in the first place, Visual Studio. If I may offer you some advice, the last-minute cramming that you will do in the 1 hour before the test, or perhaps 2, is of actually negative value to you. All you're doing is stressing yourself out about the test. What is in your brain is in your brain. The die is cast at this point. You must just write the test. So you might as well do this class, think about something else, rest your brain from databases for a moment. It won't do you any good, so don't try it. I mean, in certain rare cases, you do have, like, you know, sort of people with atypical brains that can do that sort of thing, but so if you're that type of person, you're probably already aware, but you know, just, you know, don't worry, just learn to stop worrying and love the test. Okay. So, let's continue our discussion of cookies. There's something that I wanted to talk to you about with cookies. I forgot the cookies again today. I'm sorry. So, are you going to work? Yes, surprising. All right, I probably left it here. So, cookies allow advertising, right? In an internet prior to the existence of cookies, there was no effective way to do internet advertising. After the development of cookies, we now have the fully commercialized internet that we all know and love, right? So, it is useful to discuss what the actual mechanism is that allows internet advertising, right? So, we've already touched on the idea that a cookie can be a unique identifier for a client because you send an ID number in the form of a cookie. When the client returns that same ID number, you know who you were you know that's the same person you were talking to before, right? So, let's imagine we have a person with big ears. There we go. A person is a general user of the internet. Let's say we have 2 websites, website A and website B. Let us say that A and B advertise for, put the arrows the other way, I think. A and B advertise for website C. The hello world of internet advertising is the banner ad, right? So let's imagine that on both A and B's website, there's a little banner ad that says, click this or you'll die. And that's the advertisement. Very compelling, right? Basically, it's just an image. When you click on the image, it's a link to person C's website, right? I'm sure we've all seen these before. So the question that arises is, if a person is visiting website A and clicks on that banner ad, how does website C know where the person arrived from, right? Because this is important. The way that internet advertising works is you get paid for clicks, right? When somebody clicks on the ad, website A makes a very small amount of money paid to them by website C for having this user directed to website C. But how do we know? From the perspective of this server, in the absence of cookies, there's no way to tell where this person requesting the page came from. Was it just a natural person looking at the website, right? Did it come from a search engine? Did it come from one of these points of advertisement? There's no way to tell. We have no way to identify different users. Even going further than that, if a person fell asleep on their keyboard and just happened to fall asleep on like Control and R, right, and was continuously refreshing the page, this website cannot even distinguish between, 5,000 hits from one person or just 5,000 hits. It's not possible, right? It's client-server architecture, and the clients are built to be anonymous, right? So, this is what happens. When a person visits website A gives them a cookie. The cookie might say something like advertiser ID 103, right? Whereas this website will issue cookies saying advertiser ID 327, right? So, when a person travels to website C, they send along this cookie saying advertiser ID 103. C is able to pick that up and say, aha, I have a user coming in who has this cookie. Apparently, at some point, this person visited advertiser 103. I will now credit advertiser 103's account by 0.000003, Argentinian pesos or something. So, site A gets paid, site B does not. Does that make sense? Now, this hopefully doesn't quite jive with one thing that we know about cookies. Right? Anybody have any idea what I'm talking about?
They have a very short lifespan.
Well, they have a short lifespan, but so long as, there's probably nothing restricting this advertising website from leaving this cookie persistently on a person's computer in the hopes that they might eventually visit this website of their own accord, and that would count as a click even though they didn't click the banner ad. So you have every incentive as an advertiser to not have your cookies expire, right? Now there's something else I'm talking about. It's this bit here, right? Where this cookie is sent to website C.
The user can clear cookies or edit them.
Say a little.
The user can clear cookies or edit them.
The user can clear cookies or edit them, yes, but that's not quite what I have in mind.
Try again.
Yeah?
How does website C know that the person has that cookie because the person never directly interacts with website C?
Well, they do directly interact with website C when they request a page from it. One thing, so, alright, so this is what I'm getting at. Your browser has stored a lot of cookies, right? A lot of cookies for a lot of different websites.
So maybe both the websites can have the same advertiser ID.
Well, possible, although the way that this is done is not with like bare integers. We'll get into it a little bit later. These will be cryptographically secure strings, not like just integers.
Would it be a globally unique identifier, potentially?
Yeah, well, these we'll get into uniqueness according to cryptography. That's a whole nother tangent.
You brought that from databases, actually.
So the problem, this is a cookie being sent to domain c.com, right? But it did not originate in c.com. It originated in a.com, right? So this is a special type of cookie called, dun dun dun, a third-party cookie, right? I'm sure everybody's now heard of third-party cookies, right? So a third-party cookie is one that is sent to a website that did not originate it. If a person is the first party, c.com is the second party, a.com becomes the third party, right? Now, basically, like, the war between advertisers and people trying to prevent advertiser tracking, right, falls along these lines, right? You can absolutely get browsers and browser extensions that shut down third-party cookies. Here's an issue, though. You want to know who one of the third parties is? Google. Google Ads is like 95% of the ads on the internet. So, which browser do you use?
Firefox.
Firefox, that's a good one, yeah.
Right.
Lots of people use Chrome. Who makes Chrome?
It's also kind of problematic because Chrome is based on Chromium, and almost every browser out there is built on Chromium, except for Firefox.
Yes. Yeah, exactly. So basically, like, this is the state of the advertising war, right? It's people trying to sneak these kinds of cookies through, other people trying to block, set the software up so that these sorts of things are blocked, and that is the state of the modern internet. Occasionally, I say something somewhat conciliatory, like, if there wasn't such a thing as an advertising cookie, then people wouldn't be able to make money off of the internet, aside from like directly selling things and stuff like that. Like, there'd be no such thing as an influencer, right? But then again, if there was no such thing as cookies, there'd be no such thing as influencers. So maybe that would be a good thing for humanity. But yeah, that's, ad revenue is, the world has become a very complicated place because of just little pieces of software that little key value pairs that are being passed around this great big thing that's doing things it was never intended to, by which I mean the internet. But does that make sense? Third-party cookies, we understand? All right, so here are some questions. As developers of web applications, i.e. all of you, we should be aware that there is a fair amount of legislation revolving around the use of cookies. What sort of information are you allowed to track and keep track of, right? So here's like the hint. This is what you should do, right? Your company either needs a lawyer, right? Or you just do what Europe is doing, right? So the European Union at the moment has the most restrictive set of rules around the use of cookies. Websites which can be accessed from Europe must be compliant with these. Basically, if you want to change your website so that these rules are not the case in like the different regions of the world, you're basically stuck with the problem of like, okay, well, I've got the North American version of the website for North America. Even worse than that, I've got the Canadian version for Canada. I've got the Californian version for California. I've got the Utonian, what's the adjective for Utah? People from Utah. Utahns? Anyway. People from Utah have their version of what the internet rules are, and basically, you either make like one version of your internet, a version of your website for every region that has different laws concerning the use of the internet on the planet, which is a bit crazy, and you would have to be a very large firm to be able to pull that off, or you just play to whichever region has the most restrictive ones, and that is Europe, the European Union at the moment. So, so yeah, you know how a number of years ago, the little pop-up asking you to consent to the use of cookies became a thing, right? So far as I'm aware, there's no legislation in the United States that requires that. I'm not sure about Canada. Certainly it's required by the European Union, so it's everywhere now. And that's kind of how the internet works at the moment. So, does that make sense? So basically, you know, it's possible to track a lot of user data using cookies. And sort of be evil and sell people's data to people. That is totally a thing people do for money. However, you know, you're always kind of skirting the edges of what's legal in some jurisdictions. So my advice to everyone is to just don't be evil data sponges and just do your website, and you know, you probably won't get a visit from, you know, the Interpol or whoever it is that enforces these things. I don't know. But anyway, does that make sense? All right, legislation, don't cross legislation, right? Everybody must be a good citizen. Yeah? Okay, good. So shall we talk about what a session is then? Good. Sessions, so if you understand what a cookie is, and what the point of a tracking cookie is, then you should be able to understand sessions without too much trouble. It is possible to track sessions in ways that are not cookie-based, but this is generally a terrible idea. Don't do it. Like, it's possible to pass a session idea around using post parameters. Don't use get parameters. Your session ID, for reasons we're going to explore, is basically about as damaging if it gets leaked as your well, it's less damaging than your password, but it's certainly not something you want to get leaked. We're going to talk about session hijacking once we've explained what a session is. All right? So, what is a session? Well, let's start with a cookie. We have our erstwhile client, as ever, represented by a CRT monitor. We have our server. Very good. Upon initial contact, the client has no cookies to send to the server. The server responds to the client with whatever the requested resource is, along with that cookie. So let's say the client is requesting index.php. The response has cookie plus index.php. This is an important thing to understand about cookies. I'm sorry if I didn't make this sufficiently clear before. The cookie is attached to an existing transaction. The transaction does not occur only for the cookie. It doesn't get its own packet, right? So, and let's say that what we send is ID equals 7, right? At the same time that we have set up this cookie saying ID is equal to 7, the server sets up an entry in an internal database for user 7. You can think of it as a little JSON, a little clump of JSON, right? Now, this is not the same thing as an SQL database. This is something that we will be talking about next week, the week after kind of territory. This is not an SQL database. This is a session database. It is maintained by the web server. Because we're talking about PHP and Apache servers, this is maintained by the Apache server. You don't have to have a second server instance running to get the session database. It's built in. Okay? So, the PHP script may populate this database entry with whatever data it thinks is useful. Now, on the next request, ID is equal to 7, the server, as its first step, or close to its first step, actually whenever you use the function, but you should use the function like as the first line, right? It says, oh, that is an ID for a session. I may have that in my database. So it consults its database, says, oh look, I found an entry for 7. It takes this data and it loads it into the PHP script for use. It then chugs. Maybe it sends some updates to the session. And it sends its response. Does this make sense? Hopefully. So, what this gives you effectively is somewhere to put data where it will be maintained across calls to PHP scripts from the same server, right? Before now, when we ran a PHP script, unless we were writing things into the file system on the server, all of our variables are lost whenever the PHP script ends, right?
So is this like when you return to a website that you use frequently and you open it up and you're still logged in on the website? Is this why that happens?
Yes.
Okay.
Yes. So, yeah, login is like the quintessential example of a session. In fact, a lot of times you just call it the login session, right? That's even terminology that's migrated down to the level of normies to an extent, right? So, yes, but we're not quite to login systems yet. All we have is the ability to have data persist for one user across multiple accesses to PHP scripts. This was something that was not possible before, right? Unless we were to replicate this whole mechanism ourselves using something like a post parameter, right? We could send back something that JavaScript is supposed to pick up as a value. The JavaScript sends it back, right? But even that's not really a great solution because JavaScript isn't persistent either, right? With a session cookie, the cookie is stored on the browser and it either is deleted manually or it expires, and that's what ends your session, right? Well, it depends on the type of cookie, but generally, yes. Does this make sense? So, any questions? So to break a session, how could we do that?
Just modify it.
Modify the cookie. If, for example, we have some slightly mischievous client who changes the 7 to an 8, right? We don't have an entry for 8. So it kind of depends on how the system is configured. Sometimes it's like, oh, 8, well, here you go, here's one for 8 then. But you don't have access to the previous data, so the session has been broken. Another way to do it is to just delete the cookie entirely. If you delete the session cookie, you've broken the session, right? If the cookie expires, that also breaks the session, right? So it's normal for an online bank on their logout screen to say, okay, now go clear your cache, right? The reason that they tell you to do that is that inside of your cache is a cookie that's not expired yet for the session, even if you have invalidated the you've invalidated the session.
Maybe someone take the cookie, can access your account.
If someone takes the cookie, they can absolutely access your account. This is known as session hijacking, right? But before we get there, I'd like to digress on the topic of cryptography. So here's a question. If our system just numerically identified clients, right? If you modified your cookie to 8, you would get someone else's session. This might be a login session for someone's bank, right? So you don't want people being able to guess other people's ID numbers, right? So what do?
You make them hard.
You make them hard to guess, right? You make not just hard to guess, very hard to guess. You make them so hard to guess that someone could guess at that number for the amount of time that the universe is old, and they still would have a very, very, very low probability of guessing correctly. That's what you do. And this, my friends, is cryptography. So, elementary principles of cryptography. Number 1, if you're guessing numbers, larger numbers are harder to guess than short ones. Pretty obviously. If I have, if I play a game with you, right? Guess a number between 1 and 10.
8.
Right, but you've got a 1 in 10 chance, right? If I say, guess a number between 1 and 10 million.
47.
You've got a 1 in a 10 million chance, right? So the more complicated the number is, the harder it is to guess. So that's the first very important principle of cryptography, right? So, mathematically speaking, if we say, our number is n digits, right? The complexity, if we're talking about decimal numbers, and that's a hint for where I'm going with this, the number of possible guesses, the number of possible values that we would have to guess through is 10 to the power of n, right? So if you make n big, right? If you say make n 64 or something like that, something nice and base 2, 10 to the power of 64 is pretty friggin' big, right? Pretty friggin' big. The number of seconds that have elapsed since the beginning of the universe is 10 to the power of 14, right? So, we're already doing pretty good, but we can do better. What if we used hexadecimal digits, right? Hexadecimal digits, you guys have done hexadecimal digits, right? Yeah, so how many, what's the base of hexadecimal? 16, right, so we get 16 possible values here instead of 10. Oh, now that's even better, right? So how many characters are there in the English alphabet? Or in ASCII anyway, right? So if we use all of the numbers plus 26 lowercase letters plus 26 uppercase letters, and let's throw maybe 10 or 12 additional characters in there, hashes and hyphens and that sort of thing, right? All the stuff along the top of your keyboard there. We start doing quite well, right? We're now talking, 72? 72 to the power of 64? Come on. It's very, very, very good. Right? So, you folks know what a brute force algorithm is?
Test every possible outcome until you get one, right?
Yes, they talked to you about this in testing, right?
No.
No? Oh, where did you hear it then?
Just around.
Just you've absorbed the
Yeah, you
information
did,
by
yeah.
osmosis? Yeah, okay.
Yeah.
So, for the benefit of anybody who has not absorbed that definition by osmosis, so a brute force algorithm is a simple algorithm which attempts to calculate a result by relying on being willing to take a very long time to do so, right? So, the brute force algorithm for trying to crack someone's password is, well, let's try A, no, okay, AA, no, AB, okay, AC. That's the brute force algorithm for passwords, right? Now, as computers get faster and faster and more distributed, the floor, or I guess you could say the ceiling for the effectiveness of brute force algorithms is continuously rising, right? A password that was a good password 20 years ago could very well not be a very good password today, because we can brute force things a lot better today than we could 20 years ago, because computers are faster, right? And memory, like, you know, this is exactly the type of operation that you could send to a GPU as well, do like massively parallel calculations, right? But basically, what you're trying to do is overwhelm a brute force algorithm with complexity, right?
Possible value.
Yeah, like, let's say that this is the complexity of your system, right? By the way, if you enter into this into a calculator, I don't think it will even calculate it,
It's like, yeah.
right? It's really, really, really big. It may exceed the size of a floating point number at its maximum. I'd have to take a look. But I think floats only go up to 10 to the power of 128. I could be wrong about that. So basically, the question is, if these are your ID values, how easy is it to guess somebody else's?
Really difficult.
Really, really difficult. And it would take many, many, many iterations of the entire length of the universe to do so. Assuming your computer didn't break, right? And here's the other kicker for you. You only have 22 minutes, because that's how long the cookie lasts, right?
What happened if you copy the cookie somewhere else?
See, that's a different issue, right? If the cookie, like if a valid cookie value, session ID, is stolen or accidentally shared, you have a duplicate session. You have two computers logged into the same session. One for, you know, some poor, sweet, innocent grandmother who clicked on an email link, and, you know, dirty, damned, evil hacker, right? So, but I have a whole thing for that. Patience. Patience, my friend. So, but here's an interesting, here's an interesting corollary to that, right? A corollary is a secondary result, aside from your main result, resulting from logical premises. So, a secondary result of that, it's not only almost impossible for someone to guess your session ID, it is also almost impossible to regenerate one randomly using a random number generator, right? Even if you're not checking the existing values and like saying, oh, wait, that one already exists, we can't use that one. You don't even have to do that, right? Because the likelihood of that happening, the likelihood of two people randomly getting the same 72 character, 64 character long random password is so infinitesimally small that you could rerun this universe like once for every atom there is in this universe, and then do that for all of the atoms in all of those universes, and you probably still wouldn't see it. Right?
So basically cryptography is just, if you have so many different values, the bigger the value you have, it's impossible to guess, right?
Yes, and this, this is leveraging a mathematical result called the state explosion problem, right? So if we talked about characters here, but this also applies down at the level of binary itself, right? How many possible states are there in a 1 bit, in 1 bit? How many possible states? 2, binary system. How about 2 bits?
4.
How about 3 bits?
8.
How about 4 bits? 16, 32, 64. Each additional bit that we add doubles the search space necessary to find one number in all of those numbers, right? Now, it's definitely possible if you're, if you're talking about like 2 maybe integers, 32-bit integers, you can do that reasonably quickly, right? But at a certain point, there is just too many possibilities that you cannot possibly calculate all of them. This is why exhaustive testing is impossible, right? They've told you in your testing course, I hope, that exhaustive testing is impossible, right? Perhaps they didn't tell you why?
They just said it's impossible to get 100% code coverage.
Yes.
Well, not feasible.
I mean, well, actually, I would argue with that. Coverage testing just means you've exercised every branch of the program.
Maybe not phrased correctly then. It was
Yeah.
like if we have like a very long array full of potential values, you want to test stuff at the boundary and then maybe one in the middle, but you can't really do all the stuff in between.
That's the yeah. I haven't actually taught the course, so I'm not quite sure what terminology is being used, but like I kind of did my PhD in testing adjacent stuff, and coverage testing is like, have you exercised, like, if you have a complicated system structure of if statements, do you have at least one test corresponding to every branch of every if statement? That's coverage testing, but that's okay. Whatever they said in that class is right for your exam. So like, let's say you were talking about an array of integers, right? Let's say you were testing to see, let's say you had an algorithm to, like quicksort or something, right? Something to sort integers. Are you going to be able to test it on every possible array? No. That's right. Because of the state explosion problem.
There's infinite number of potential arrays.
Well, not infinite, but close enough to infinite that you can't do it, right? Numbers can be very, very, very large without being infinite. But you also at some point run into the physical limitations of the machine, right? But yeah, so the state explosion problem has kind of 2 edges to that particular sword. The side that cuts us is we cannot absolutely verify the correctness of program because of the state explosion problem. There are other approaches, like formal mathematical proofs of correctness, but these are generally impractical. But the side of the sword that we use for cutting is cryptography works. Cryptography only works because of the state explosion problem. So while we cannot exhaustively test our programs and verify absolutely that they work, we also get all of the benefits of people not being able to guess our secret numbers, right? So, does that make sense? Any questions? All right. So when you are selecting, when you're selecting an ID, given that you are now in the role of PHP, the programming language, when PHP selects a cookie ID, it's pulling one. It's generating one of these, something very large that's difficult to guess. I would say that probably PHP session IDs are not as long as I would like them to be. There's absolutely no reason you couldn't do 256 characters on one of these, right? The more characters, the more secure, and characters are cheap, so why not use more, right?
That's why your password is so long.
That's why we finally came around to it. Yes, this is why my password is so long. I'm generally not satisfied with a password unless it's like my happy point is like 30 characters. right, for a password, which, like, even if it's as long as it's reasonably immune to dictionary attacks, it's unbrute forceable. So, and like, oh, I've got some scary stuff to show you about passwords, but not until we've done password systems. So yeah, sessions though. So now let's talk about how you actually do this in PHP, right? This has been a long discussion of theory that has set up two very simple things, arguably three. To start a session, session start. Right? All of this tracking with the cookies is being handled for you. You probably shouldn't mess with it unless you have a good reason to, because some of it is security related. But you start a session using session start. This should be placed right at the top of your file. It should be open PHP, right at the top of the file, session start immediately, if you're using a session. So far, so good? That's the easy part. Question?
So is that before or after a set cookie then?
You do not use set cookie if you're using a session. It is actually, I don't mind telling you that on the last exam that I put together for this class, I put a question on that exam where someone was trying, like it was code that was trying to use set cookie to establish a session, and the question was, what is this person doing wrong? And the answer was trying to use set cookie to establish a session. That's what they were doing wrong.
How did you send a session to a person that is the first time that they access the website?
So the first time a person accesses this PHP script, this function itself calls set cookie, right? But it sets the cookie with like particular values set. It generates one of those things, sets that as the session ID, hooks it up to the database for you so you don't have to. It does all of that for you in one line, right? Now, session start is a little bit of a misnomer. It is not only starting a new session, it is also reconnecting to an old session. Both of those functions are wrapped up in session start. So you can write your PHP code agnostic as to whether this is the first time the user has accessed this, or, am I returning to an existing session? In both cases, session start is the way to do it. Make sense? So far, so good? Don't worry, we will have plenty of code examples. So, what is the session? Well, this is PHP, so it's a superglobal. After session start has been called, you have access to the session superglobal. Now, the session superglobal is a little bit different from the superglobals that we have been using so far, right? Whether it's get or post or files, we have been thinking of these correctly as read-only buffers, right? That's not technically true. You can write into them, but it's a bad idea. Why would you want to? Why would you need to? This is where PHP puts the important information that your script needs. It's like that vague rule they sometimes mention that you shouldn't modify the arguments to a function, like inside the function, right? You guys ever wonder why they tell you to do that? Tell you not to do that? Yeah. Have you ever, well, I should back up. Did they ever tell you that? That you shouldn't modify the arguments to a function?
So I think it's because if it is a array, then the whole array gets modified in the main function.
Yeah, it depends on the language, right? So that general rule, don't modify things that come out of arguments. Don't modify the arguments themselves. Some languages pass by value. Some languages pass by reference. Sometimes languages pass references by value, right? Like in Java, right? Java is passed by value, but when you pass an object into a method, you are passing a value, which is actually an object reference, right? So the value you're passing is itself a reference, so objects get passed by reference, whereas like primitives get passed by value, right? So it just kind of avoids all of that completely. Just don't modify them. Don't modify them and you don't have to worry whether it was passed by reference or passed by value, right? Where possible. Now, sometimes the whole point of passing an object to a Java method is that you're calling a method on it, right? You know, it's kind of like, it's one of those hand-waving rules. It's like, this isn't a fixed rule. You may violate it as you wish, but it's generally good practice to not modify arguments to functions. It's kind of in the same category of rules as it's good practice to not use global variables if you can avoid them, right? So yeah, same thing applies to most superglobals in PHP. They contain data that's been plumped down there by the server. So just leave them, read them, do what you want with them. Just don't touch them, right? Look, but don't touch, right? Just as your parents used to say in all of these, very fancy China shops that I'm sure you were drugged through as children. Look, but don't touch. This one's different. The session superglobal should be thought of as a read-write buffer. You are, if you don't write into it, you're not going to have anything in it to read from, to read. So the thing comes to you empty upon initial creation. There's nothing in it. It links up to an entry in a database. You throw data into this thing by writing to it the same way you would write to a regular associative array. When the PHP script closes, changes made to the session superglobal are written to the database. On the next load, if a session ID cookie is received from the client matching an entry in the database, this information is pulled out of the database and put in the session. So this is where that stuff ends up. Does that make sense? So, the whole purpose of session start is to make this available to you. It gets automatically handled for you. You don't have to worry about it too much. It's just, that's where you keep your data. Make sense? Any questions? All right.
So,
Yes?
So you said when the session closes, by calling like the session close method, that's when the write actually happens?
The write, well, there is actually a function that you can use to manually write changes into the database. But this is automatically done when the PHP interpreter shuts down for this PHP script.
Okay. So
Right.
you don't even need to call a method, just,
Not unless you have a reason to. You might have a reason to, but in most cases you won't have a reason to. When you reach the end of the file, any changes made to the session superglobal are automatically saved into the session database. Make sense? Okay. So, there's one more function that we need to talk about. Session unset. So, there's a little bit of debate about this, or at least there's stuff that was true historically that isn't true anymore and yet is nevertheless represented in the lecture notes for this very course, unfortunately. Session destroy is an old way of doing things that you shouldn't use anymore, according even to PHP's own documentation. If you need to get rid of a session, or get rid of the values inside of a session, session unset. Right? Session unset destroys all of the data inside of the database entry. Now, this thing should be inside of at least an if statement, right? If you start the session up here, use the session variable, and then have unset the session before you close the file, nothing will ever be written to the database, right? You're destroying the data immediately after setting it. You're not allowing it to persist to the next call to the same PHP script, right? Make sense? Good. Any questions? All right, let's see if we have time for an example.
What type of information?
Oh,
What type of information can be saved inside a session?
well, you can literally just make variables and drop them in. So, literally anything. The example I'm about to do is site visits for specific users, right? You remember how a few weeks ago we did the file I/O example of like the site counter, right? Sessions allow us to have one for each individual user, which is kind of interesting.
Okay, so I assume that in that sample you will have put a variable inside the session port, and every time you detect that a specific user accesses the website, it will add one to us. Is that save to the database?
Yep. Yeah, you'll the code for it is quite straightforward. Please load the thrice accursed XAMPP from Mohawk, the quad, the 4 times accursed Mohawk apps anywhere, please. So like, what's going on that like first AWS, now Azure? Like,
Yeah, both went down at the same time.
what's going on? Like, is it the Russians?
Microsoft says it's like a complication. They change something, then MSU will roll back.
Wait, they pushed an update that broke things?
A configuration issue, yeah.
You know, this reminds me of that Microsoft press release how they were bragging that 30% of their new code was written by Copilot.
Gee,
Why do you think?
I mean, I know like for
Just read the configuration
Amazon,
quickly, but
thing
it
like
makes this
that
happen.
last week, apparently their system was recommended at the same time, that's why it crashed.
okay, can I give everybody some advice right here, right now? Alright? If you have anything you care about on cloud storage, go buy a hard drive and put it there. Okay? Local storage is still king. Alright. So. There you go. It's kind of interesting, because like who's in favor of AI? I get I get the impression that like people sort of in your cast are generally fairly anti-AI. You know, I think it's mostly Gen X people. I think it's Gen Xers who are responsible for this one.
It's just like hype is all.
I assume
Yeah.
I assume it's like the C-suite who went goo gaga over the monkey JPEGs.
Yeah, I mean, that's all you really need to
So
like crash the.
NFTs.
It turns out that's all it takes to set up a huge bubble that's going to crash in the in the stock market. Is like, oh look, this program produces slightly fancy images. Ooh, we better crash the economy over this. Yeah, like definitely, it seems like it's like people who like don't really want to do their jobs mostly who use AI. You know.
Or just people who buy into it and think that it can save them all the money by just having the AI write stuff for them instead of people.
I think that's what I just said. We just said the same thing, but slightly differently.
Yeah, fair enough.
I mean, I don't know. It's interesting. I feel like the bubble is like, come on. Like, I know it looked originally like it had a pretty thick skin, but like gravity is doing its work. The top of the bubble's getting pretty thin.
But you don't like shopping for cooking appliances, and it says on the device that you buy, this device is AI powered.
Oh man, someone at the Game Dev Club who may be in this very room had a really funny one that VS Code, or not VS Code, Visual Studio suggested. It was like, it was like, you know, public, it was like public book, and then it equals new book, like an instantiation line for an object, and the class was book, but like the suggestion was bool. So it was like using bool as like the class identifier, and that was its suggestion. It was pretty funny. It was pretty funny. It's like, oh my goodness. I think it's getting worse. I think it's getting worse.
I mean, because
Garbage
it's, yeah, just, it's training itself on other AI garbage, so it just gets more and more distorted, I think.
Yeah, it's,
That one wasn't AI.
that one wasn't AI?
No, I specifically disabled Copilot for it. That was just the default Visual Studio recommendation.
Oh, okay. Well, woof. Alright, anyway, so, session starts. Let's say you have visited this site